In this video, I'm going to be talking about section 8.2, which is all about confidence intervals for one population mean when its standard deviation is known. To start off, I'll be showing how to find a confidence interval for any confidence level. In general, we want to write the confidence level in the form of 1 minus alpha, where alpha is a number between 1 and 0. So if the confidence level is expressed as a decimal, alpha is a number that must be subtracted to get the confidence level. So for example, if the confidence level is equal to 95%, then alpha is equal to 1 minus 0.95, and you get 0.05. So now that we have some basic background information, let's go through the procedure for finding the confidence interval for a population mean mu. So to start off, we'll need to make several assumptions. The first assumption is that we have a simple random sample. The second assumption is that we have a normal population or large sample. And the third assumption is that standard deviation for the population is known. And after we make our assumptions, we can begin our process for finding the confidence interval. So for step 1, we're going to be using the z-score table, or if you have the book, it's going to be table 2 in the back of the book to find z of alpha of over 2, which is going to be our critical value. Step 2, we're going to calculate the margin of error, which is denoted by the letter E, using the formula that you see right here. E is going to be equal to our critical value times our standard deviation divided by the square root of our sample size. Following that, we proceed to step 3, which is we're going to establish our confidence interval, which is our sample mean plus or minus our margin of error. As you can see, we have our sample mean here, and basically we're just going to be subtracting or adding the margin of error, and everything between here is going to be our confidence interval. And following that is step 4, where we interpret the confidence interval. So now let's apply this procedure to a problem from MyMathLab. So here's a problem from MyMathLab where we're given the sample mean, the sample size, the population standard deviation, and the confidence level. So part A of this question is asking us to use the one mean z interval procedure to find a confidence interval for the mean of the population from which the sample was drawn. So let's follow through the process or the steps I just outlined earlier. So for step 1, we're going to be using the z-score table to find our critical value. So based on this information, we know that our confidence level is 95%. The next thing that we're going to do is we're going to find our alpha. So our alpha is just going to be basically subtracting 95% in decimal form from 1. And that's going to get us 0.05. Now we need to refer to our z-score table. So here we have a standard z-score table. This one's been taken from the back of the book. And if you remember, our alpha value is equal to 0.05. Now if we divide that by 2, we get 0.025. Now we're going to be looking up that 0.025 value along here somewhere. So as you can see, that number is going to fall right here. So from here, we're going to be going first to the left to get our first two numbers. And then we're going to be going up to get our third number. So our critical value is going to be equal to 1.96. In the example here, we're going to be ignoring the negative sign, but in other cases, you might be paying attention to it. So now let's go back to the rest of our problem. So we take our critical value of 1.96, the population standard deviation of 2 that was given, the sample size of 37 that was given, and we're going to plug it all into our margin of error formula here. So plugging it in, we get 1.96 times 2 divided by square root of 37. And when we calculate it out, that comes to 0.644. From here, to get our confidence level or our confidence interval, we're going to be subtracting and adding this number from our population mean of 23 that was given earlier. So we have 23 plus 0.644 and 23 minus 0.644. That gets us roughly 23.6 and 22.4. And this lets us say that the confidence interval is from 22.4 to 23.6. And now we can do step 4, which is interpreting the confidence interval. And we can say that we can be 95% confident that the mean of the population is somewhere between 22.4 and 23.6. Now that we've seen an example, let's talk about when to use this one mean z interval procedure. So there are 3 different cases that you can think of. When you have a small sample, or when your sample size is less than 15, you can only use this procedure, or you should only use this procedure when your variable is normally distributed or very close. For moderately sized samples, for those with a sample size between 15 and 30, you can use this procedure unless the data contains outliers or the variable is far from normal distribution. And for large samples, when your sample size is greater than 30, you can use without restriction, but you should be checking the results with and without outliers to see if there's a significant difference. If there is, then you probably should be considering another procedure to use. Let's now talk about the different things that can affect confidence and accuracy. If you remember, our margin of error indicates the accuracy of the confidence interval estimate. The size of the margin of error can be controlled by 2 things. The first thing is the confidence level. When we decrease the confidence level, we decrease the critical value, which leads us to decreasing the margin of error. When the margin of error is decreased, this improves the accuracy of our confidence interval estimate. And obviously, this will be completely reversed if we increase the confidence level. Now, the second thing that can affect accuracy is sample size. When we increase the sample size, this decreases the margin of error and also improves the accuracy of the confidence interval estimate. And this is because the sample size appears in the denominator for the margin of error equation. So how do we determine the required sample size if margin of error and confidence level are given, but sample size isn't? If we remember our margin of error formula, we can modify it to calculate the sample size. And it looks something like this. We have n, which is our sample size, is equal to our critical value multiplied by our standard deviation divided by our margin of error. And always round up your answer to the nearest whole number. Now let's take a look at another problem from my math lab. This problem gives us a 95% confidence interval of 17.5 months to 48.7 months has been found for the mean duration of imprisonment, mu, of political prisoners of a certain country with chronic PTSD. Question A asks us to determine the margin of error, or E. In this case, you can see that we can't really use the formula, but we are given a confidence interval. So what we can do to find E is we can subtract 17.5 from 48.7 and divide that by 2. So that's going to give us 15.6, which is our answer here. And then question B asks us to explain the meaning of E in the context in terms of the accuracy of the estimate. If you look at the different choices available, choice A is the best one, and choice A states that one can be 95% confident that the maximum error made in estimating mu by the sample mean is as found in Part A. Part C gives us a margin of error of 13 months, a 99% confidence level, and a standard deviation of 45 months, and asks us to find our required sample size. So in this problem, we need to calculate out the critical value, and then we can use the equation for the sample size to solve the problem. So n is equal to critical value times standard deviation divided by the margin of error. So let's go about finding our critical value first. We have a 99% confidence level. So we need to find alpha first, which is alpha is equal to 1 minus 0.99, and that gives us 0.01. Now if we divide that value by 2, we get 0.05. And now we bring back our trusty z table. We know our alpha divided by 2 is equal to 0.05, and now we're going to look it up on this table. As you can see, 0.05 is going to fall somewhere around here. So let's look at the left two numbers, which is over here. And then let's go look at our last number, which is going to be up here. And because we're in the middle of 0.07 and 0.08, the value that we're going to use is 7.5. So our critical value is going to be 2.575. So now that we have our critical value, we can plug the numbers into our equation and get our sample size. So we have n is equal to 2.575 times our standard deviation, which is going to be 45. We're going to divide that by our margin of error, which is 13. Punch it into a calculator. Oh yeah, I forgot one major thing here. Sample size, this equation, we need to square it. So if we put this through our calculator, we're going to get 79.21, which rounds up to 80, which is our answer here. Now, part D gives us a mean of 36.3, and to calculate the confidence interval, we already have our margin of error given here, which is 13. So all we need to do is add and subtract 13 from 36.3. So that gives us 23.3 on the lower end and 49.3 on our upper end. So we're left with this answer here. The 99% confidence interval for the mean duration of imprisonment mu is from 23.3 months to 49.3 months. And that does it for this video. If you have any questions, feel free to make an appointment with a tutor at the Academic Support Center. Thank you for watching.